Next, question number 13, differentiation part. Given the limit question like this, limit x approaches to 0, ex squared minus cos x divided by x squared. I can write this limit x approaches to 0. Ex squared, this cos 6 I write using half angles, 1 minus 2 sine squared x by 2 divided by x squared. Now I can remove the bracket, limit x going to 0, ex squared minus 1, here minus 1 divided by this x squared, and minus minus plus, that 2 sine squared x by 2 divided by x squared. This way I can write by separating. Now I can apply limit for this one here and here separately. X squared minus 1 divided by x squared, and here I can take this 2 out and I write the limit sine squared x by 2. Right here we have x squared. Now I divide this by 4, and to cancel down this 4 I write 4 here, that 4 I write before here, like this. Then you can write this as the perfect square of this way. Now I write that here, limit x going to 0, ex squared minus 1 divided by x squared. You know, as x going to 0, its perfect square also going to 0, so therefore I can write here x squared going to 0, right? And that 2 by 4 is half. Now this sine squared x by 2 divided by x squared by 2, I can write sine x by 2 divided by x by 2, its perfect square like this, right? And now we have limit x going to 0. Limit x going to 0 we can bring inside the bracket now. We can bring inside the bracket. And other thing is, as x going to 0, we know x divided by 2 also going to 0. So therefore, I can write here this one as limit x by 2 also going to 0. Then you know this answer is 1. The reason is this is 1 and this also 1. Therefore, here we get 1 squared. And here we have this way, right? Half. Then we get here 1 and half into 1. This is the answer, 3 by 2. We know this one, what? Ex minus 1 divided by x as limit x going to 0. We know this people 1. And this is sine theta by theta as theta going to 0 also 1. Using them only we took this answer, right? Limit theta going to 0, sine theta divided by theta is 1. Using them we got this answer. Second part, given like this, 2py equals x times q plus p dy by dx. We differentiate this first. 2p derivative of y is dy by dx. To the right hand side we apply product formula u into v. We keep this x and we differentiate this, q is a constant, and derivative of p dy by dx is p times derivative of dy by dx is d2y upon dx2. and now plus we keep this as the same, q plus p dy by dx, that should be multiplied by the derivative of x. Derivative of x with respect to x is 1. Then you can take this term to this side, then we get 2p dy by dx minus p dy by dx is p times dy by dx, and we'll bring this q also this side, minus q, and now we have px times d2y upon dx2. Now to get the answer contains only d2y by dx2. Then what we do is, here we have p dy by dx, that p dy by dx we can subject by this and put that we are here. Then the asking answer you can take, right? If I take this as star by star, you can write by star, you can write, first bring this x to the denominator left hand side, 2py divided by x, right, and bring this q to left hand side, minus q is equal to p times dy by dx. Now I can substitute for this p times dy by dx, this answer, then we can simplify, you get this answer. Therefore we get something like this, 2py divided by x, 2py divided by x minus q, right? Let's substitute for this one now, this thing, right? This thing I substitute here, minus q equals p x times d2y upon dx2, right? Now I can simplify here, 2py minus 2q, and x also come in when you take the common denominator here. Now the x we must write, and we'll take this px here, then we get px squared. Then this is the second derivative of y with respect to x. Now once I take this 2 out, py minus qx divided by px squared is the answer of the second derivative. Therefore we can write d2y upon dx2 is equal to, take this 2 out, 2 times py minus qx divided by px squared. This is how we take that answer. Part C. A running track of 440 meters is to be laid out enclosing a football field. The shape of the field is a rectangle with a semicircle at each end. Find the length and the breadth for the area of the rectangular portion of the field is maximum. Application of derivative part. Right. This is the football field. Then the semicircular ends. Say like this. Here, I'll take the radius as r. And this length I take x. Then the whole length of the track should be 440. That is, here x, 2x, and here pi times r, here pi times r. Then total is 2 pi times r, should be 440 meters. Should be 440 meters. Then dividing this by, cancelling this by 2, we get 220. We get x plus pi times r equals 220. Let us take this as the equation number 1. Now the football field is this, the rectangle part. Its area going to be x into 2r. If I take the area as A, area is x into 2r. That means area is 2rx. Right. Now we substitute for here by subjecting number 1, this simple r in terms of x. I can put that r here. Then by 1 we can write r subjecting 220 minus x divided by 5 that we substitute here. Then we get a equals 2 times x. For the r I substitute 220 minus 6 divided by 5. Then I can take this 5 out and then 2 upon 5. This x will be inside. Then we get 220 x minus x squared as the area of the field, football field. Yeah. Now we can differentiate this with respect to x to find the first derivative of a with respect to x. Differentiating with respect to x, we get dA upon dx equals this 2 upon 5 is a constant. Here we get 220 minus 2x. 220 minus 2x. 220 minus 2x. Right. Now you know for maximum or minimum a, for maximum or minimum a, dA by dx equals 0. dA by dx equals 0. Then we can equate this dA by dx, this one to 0, then definitely this must be 0. Thereby you get two upon 5 times 220 minus 2x equals 0. Then this must be 0. This gives as x equals 110 meters. X equals 110 meters. Okay, now we have to verify at this value of x. At this value of x, the area A of the field is maximum. For this, we take the first derivative test. Right. dA by dx sine x less than 110 meters. Then you can literally see here, when I substitute here for x less than 110, this difference will be positive. Next one, dA by dx sine x greater than 110, then this difference will be obviously negative. Then I can see this is the x, this is the a. At 110 of x is this, before 110 positive, 0 negative. Then x equals 110 meters, a is maximum. Right? So you can write a is maximum when x equals 110 meters. Therefore, you can say x is maximum. Sorry, a is maximum, not x. A is maximum. A is maximum at x equals 110 meters. A is maximum at x equals 110 meters. Right. So then, asking to find the length and the breadth. Right. The length is already we found. Is the length. It is 110. The breadth going to be 2r. 2r. Right. 2r is the breadth. So you can find 2r like this. Right, by 1 I can write subjecting r 220 minus x divided by 5. 220 minus x divided by 5. Then R is x is 110 no? 220 minus 110 divided by pi is 22 over 7. Then the breadth is going to be 2r. Therefore, you can write 2r. Right, simplify this, multiply by 2, then we get for 2r 70 meters. So therefore, the breadth is 110, the length is 110, breadth is 70 meters.